Hey there, welcome to dotnetFlix. So today we are joined by Niels Tanis. So welcome Niels, how are you doing?
I'm good. How are you?
I'm great. It's my
Yeah,
pleasure
awesome.
having you on the show again.
Yeah, it's the second
I
time.
guess it
Yeah, it's
was a
like
while ago even, more than a
2021, I
year I think.
believe. Something. Yeah, a bit more, a bit over a year,
Yeah,
I believe.
something like
Yeah,
that.
yeah. Okay.
So in that episode we talked about security and now the topic is WebAssembly, and I know WebAssembly mostly from Blazor and running all
Yeah,
kinds of stuff directly in your browser like .NET applications.
yeah.
But I guess you can do a lot more with WebAssembly, right?
There's a lot more goodness that I'm hopefully going to show you today. So yes, for sure. You can use it. You can leverage it. You can also introduce some new security stuff with it, and that's exactly what I'm going to talk about. So
Awesome.
yeah,
Cool.
shall we
Yeah,
continue? And
Yeah, let's
um,
dive
yeah,
in.
Yeah, okay, cool. I think important what we first need to maybe grab hold of a bit like WebAssembly in general and what makes WebAssembly secure itself. I think the first version or the first iteration of WebAssembly was done in 2015, and in 2017, I believe it became a V1, which was released and available in all the browsers. And these were like the design goals that the people have put up in order to make sure that they create something that is efficient and portable. They want to have something that's readable and debuggable. They want to, of course, keep it secure, and that's what caught my interest, of course, being a security guy, because you can do a lot of stuff with sandbox. And one goal, of course, not important, is don't break the web, right? If you break the web with your browser, then you're probably going to lose a lot of users. That's not what they wanted with WebAssembly either. They wanted to have some interop that will just work. That was one of the main goals. So WebAssembly is a binary instruction format for stack-based virtual machines, which is kind of similar to what we have with .NET and MSIL and how it executes, or the Java and bytecode combination. It's the same type of thing. It has been designed to become a portable compilation target, which means that most of the things that you can compile to WebAssembly, so you can write literally in .NET, in Go, in Python, you can all compile to WebAssembly, and then you can take that application and just run it. So what we saw at first is that, of course, because it ran in the browser context, tools like Adobe took their C code base, took a tool called Nscripten, and put it into WebAssembly. And of course, ourselves, we have seen, if you're familiar with .NET space, Blazor WebAssembly runs inside the browser. It takes a .NET CLR and runs inside the browser. We're going to touch more on that once we move into the demos. But the other thing that was also really important for WebAssembly is that the security model would would like to enforce that users are protected for any malicious models, right? If we write software nowadays, then big chunk of what we do gets pulled in from third-party libraries, which of course I always say I'm lazy as well. I'm a developer. I want to use what's already there. So you want to make sure that people don't have any risks involved with that. And also we want to make sure, or with WebAssembly, they wanted to make sure that there are useful primitives for developers to use and to build safe applications. If we then look at WebAssembly as a thing, like what makes it secure, and one thing that really stands out with WebAssembly is the way that it deals with memory, because memory itself is a contiguous mutable array of uninterpreted bytes, as you would look up inside the standards, but it's isolated per module. So each module has its own chunk of memory, and what you see over here, which is a cartoon that I took from code cartoons that has been done by Lynn Clark. If you look up, there's a lot more goodness, and I'm gonna maybe squeeze in a couple of more after this. But these are really good cartoons that will explain stuff around WebAssembly, and it's just a byte array. And the nice thing about it is that a module cannot exceed its bounds, which makes sure that not all security things are like breached, for example, right? So if you have a module, one module cannot write into another module's memory, unless you are allowed to by the one that's in control. But keep just in mind that it's an isolated piece of memory that it uses. So therefore, it's secure. Still, a module itself, if there is a security issue, you can probably imagine that logical thing, you can still overwrite data. Then there might be a security problem. The other thing that WebAssembly uses to enforce that is something they call control flow integrity. And I was looking up when I was creating a whole presentation around this topic, looking like how could you describe control flow integrity. And I think the best way is to take a piece of code, which you see here, C#, and then look through what it describes, right? So what we see over here is that we just take in a number from the console, which we store into the variable number. Then we're going to write it out. Then we have a condition branch, right? We have an if and else. So if the number is bigger than 5, we're going to write one piece to the console. Else we're going to write the other argument, like, hey, the number is smaller than 5 to the console. And at the end, we're going to say we're done. If you capture this code, and if you capture this into a diagram, it might look like something like this. The first compound is the whole thing that we take. Hey, we need to, we have a number, we're going to read it, and we're going to then check if that number is bigger than 5. And then we have 2 decision paths that we're going to take, either left or right. And we end up at the bottom where we're going to say we're done, right? So this is some kind of map of your code execution. And that's exactly what control flow integrity does. During compile time, it will determine the possible code paths that you have inside your application, running application. And once one of those code paths is not being followed, or it jumps to something else, then the WebAssembly runtime will fall into a trap, as they call it. And we will see a trap in one of my demos, but that means it will just stop executing. And that's exactly what you want, right? So based with the module and with the control flow integrity, WebAssembly as a whole is pretty secure. And that's all built on top of the language and how it's been built up. How can we then take .NET and run .NET on WebAssembly, right? First, if you look at a .NET application in general, you can abstract it into these parts, right? We have IL code, user code that's been written by somebody, that's been developed. It runs on top of your base CL, your base class library, system IO, you open up files and so on. There's the execution engine, or the VAS, which in our case is the CLR, and that runs on top of a host. What happens if we move this to WebAssembly? In the case of Blazor, we're going to get this, of course, right? The execution engine will be replaced by a CLR, which in our case for Blazor will be an mscripten compiled mono CLR that will execute the .NET code, right? And if you look into a new Blazor app, if you create it for the first time and you load it and you load up your developer tools, you will see that there's a lot of stuff downloaded, because underneath the hood, it will have the CLR, it will do some plumbing, JavaScript plumbing that it needs in order to interact with the browser. And it then downloads all DLLs, like IL. So .NET assemblies are being downloaded. And that's exactly how that works, right? And that's the whole project template of Blazor. And this is a screenshot that I took from Stephen Sanderson's talk, where he talked about Blazor in the future. And it's more like these 3 components make up your Blazor application, and the magic all comes from unscripted. But I'm not here to talk about Blazor or show you a new Blazor app, because that's not like, okay, it's cool, but it's not fun, right? We want to do the next thing. What if we want to take WebAssembly and pull it outside the browser? We need to replace the host with something else. And that's exactly something that started in 2019, because in 2019 there was also the Bytecode Alliance who was formed, which is a cooperative thing between big companies like Google, Microsoft, which has the goal of taking WebAssembly to its next level. And they started to work on something they call WebAssembly System Interface, or WASI. They also have a runtime, a WebAssembly runtime that is pulled outside the browser that can run on your system. We're going to see it in a bit. And which is a POSIX inspired, engine independent, and non-web system oriented API for WebAssembly, which in order means it's just a thing you can program against, and you can take an application and just run it against your system and pull the WebAssembly outside the browser and execute. Another cool thing that it comes with is that they have designed, and also partially implemented, which we're going to see in a bit, a strong sandbox with capability-based security. And right now, the demo I'm going to show you limits to file system actions, and we're going to do something about the amount of compute that somebody can use. But in the future, there will also be support for sockets and communication. And I believe the good thing is that Bytecode Alliance is really showing out small bits and pieces, like sharing with everybody to see how it works and see how people adapt to it. And that model is still in progress, right? Which makes it pretty cool, because it's a top-down approach instead of just throwing something and say like, hey, you need to use this. I think this is a much, hopefully, more successful way of doing this. And I think if you look at WebAssembly System Interface, or WASI, It's kind of similar to .NET Standard and what we have seen when all .NETs needed to converge into a single piece, right? That single unified BCL where we can talk against. WebAssembly WASI is almost similar. And it has another cool thing which comes with the whole security model that can be put on top of it. And that's where all the fun stuff happens, of course. How
Yeah,
do
cool,
we,
cool, Niels. So
yeah,
WASI basically replaces your browser sandbox then, right? Because if I run my .NET application on WebAssembly in the browser, I can use interrupt with JavaScript, and
yeah.
I can have access to basically all of the functions and
Or you
capabilities
will get a
that
throw
JavaScript
not
offers,
supported exception, right?
or that
That's what
that
happens.
one too. Yeah,
Yeah, yeah, yeah. Yeah, and
but
WASI is that replacement in order to talk to the system below. It's the abstraction
right,
layer, right? That takes it out of the browser. I think that's the best way to capture it. Yeah.
yeah, yeah. Okay,
Yeah,
hey,
cool.
cool. Yeah,
Yeah,
still
and
with you.
the funny thing about this is that WASI is a powerful concept because if WASI would have been put out in 2008,
Hmm.
Solomon Hykes, the guy behind Docker, said, "Hey, Docker would have had a hard time or would not even exist." And that,
Oh
of course,
yeah,
is maybe a bit of a bold statement because the day after that he said, like, will it replace Docker? And that's not the case, right? That's probably when he got a lot of people angry, I guess. But it is quite minimal. It is similar to containers, modules. And the funny fact is that in October of last year, we saw this happening, right? Docker was released with a technical preview of running WASM modules inside the Docker as a Docker container, right? So this is exactly it's just a small container, a module, more minimal. It contains less. It can run really fast, and you can
yeah.
literally take all of the stuff, compile it against. And this is also underneath the hood. It uses WASM Edge in this case, which is also a runtime, which is WASI compliant to throw in another standard, and that will make sure that it all works and that people can work their way through
Yeah, and
and
just
see.
just to be clear here, so this is not my WebAssembly application running inside the Docker container, right? This is the Docker engine directly running the
A
WebAssembly
shim that
module.
takes the WebAssembly runtime to run that single module that you're
Yeah,
using, right? Yeah,
cool.
exactly. So I think this is quite like powerful as a whole, and definitely for much smaller and can coexist as Docker already shown. And it's like Fermion with Spin. There's a lot more good stuff happening, which we're not going to touch with this because it's probably too short. But if we then get back to the model we saw before on the application, we can draw this picture, right? We have our virtual execution engine which runs on WebAssembly, and we also have the WASI runtime itself or the WASI layer that takes care of all the system abstractions we need to run. So this is the end story. And can we use this with .NET? And this is exactly what Steve Sanderson showed in a presentation he did a year ago, Build, where he showed, hey, we have a experimental WASI SDK where you can take a console app that will be compiled against WebAssembly, and that will then run in a WASI on top of a WASI compliant runtime. And that's exactly what we're gonna do right now and what we're gonna dig into a bit more. So let me move to code because now the fun starts. It is experimental. There's no guarantee that it will be finished, but there is some work being done right now. There are some issues on the GitHub you can follow where you can see WASI is being put in progress. So I have good hopes that it will eventually end up in our code in our toolbox, because you can also going to see it's probably going to be a bit rough with code and the stuff that we're going to do. But I can assure you it works. So first, let us look into this. This is a console app, and the only thing that is different compared to a normal console app is that we have a package reference that references the WASI SDK. Not sure if this is the real latest version, but this was the latest version when I wrote this demo a couple of weeks ago. So, and there is something else inside this. We just write down, in this case, what type of OS are we running on, the OS architecture, because that will be different, right? So if we now say .NET build of this same console app, and if we now take the bin debug and we say the console app itself, this is the executable that runs on my MacBook, right? We will see that it says like, hey, I'm running on ARM64 here in the bottom. I hope everybody can see that. So this means that this is running on my system locally. If I now say .NET run on this project, you will see that the output is a bit different, because what happens underneath the hood over here is it will take WASM runtime, and it will execute the module. So if we look into bin debug, and I can better do this in the Explorer, you will see that that is a WASM file. And this WASM file contains, once again, the virtual execution engine that we need and all the DLLs. But in this case, it's embedded into a single file. So this is a single WASM file that we can run against WASM time. So if we say WASM time, and then we say bin debug, we're going to run the WASI file, the WASM file itself, we will say that it's WASM time, not WASM time. We will see that it will give us exactly the same output, right? So this is what happens underneath the hood. And from now on, I'm just going to use WASM time, but .NET Run is a reroute. I believe they're also going to do WASM Edge. They want to do more, but that will give you the whole experience. So what if right now in this context, we're going to look into a bit of the sandbox. What if I want to say, let's read a file content. So let's say I want to open read all text from my file on my system, and then say console write line, then write it out to the console. If I now say .NET build, we will get a new WASM runtime. If we now do the .NET real executable, we will see that it will nicely show us the same console write line, and then it will show you my etc host file, which also says I have some Kubernetes local IP defined, right? This is the file that's on my system. You can trust me on that. If I now say the same with WASM time, and just do it's
you're missing the M again.
Yeah, we're missing the M again. Now it's in my cache, right? So I need to make sure I can also do like this. We will see that it will fail. So what happens here is that WASM time wants to open a file. But as I said, the capability-based sandbox by default has no system file access of whatsoever. It's been declined by default. In order for this to run, I need to type in WASM time, and I need to pre-open a dir. So if I say WASM time, I typed it, okay, I believe with dir. This is the command I want to talk. So now I'm going to say, you're going to pre-open this directory, etc, and then you run this file. What happens then is that we have succeeded because we have instructed the runtime itself to allow to open that folder and to read that file. So this is the capability of the whole file system that's been abstracted by WASI, but it has all the security on top of it. And you need to be explicit in order what to open and what to read. It even has no access on the running folder right now. You need to give that explicit as well. So you can open the files, and you cannot even access the current folder itself. It needs to have explicit permissions to do that as well. So it's definitely a sandbox, which is disallowing everything by default, and you need to be explicit. So that's pretty cool. If we look into the baseline right now, we've taken .NET and we run it on top of WebAssembly. So right now I want to move into a demo where we're going to take .NET and run WebAssembly on top of it. So let me see the following thing. So this is the extend application. So WebAssembly modules can be compiled and written in different variants of languages. And so what I've got over here is a demo, and we're going to see a bit more once we get back to this. But I have a Rust module that I wrote, and that Rust module, we're going to show you a bit of Rust code, does a thing with files, right? Because we want to talk about a file sandbox as well, but you don't need to fully understand this. But what it does, it is a console app, as you can probably see, because it has a main function. It reads arguments, right? It's quite similar to what we would have done in C#. And what it does, it will take a file input and it will try to copy a file from to. And that's exactly what the top function does, right? So this is all there is. If we now do a cargo build on that, to make sure I'm in the right folder. So that's the extend my Rust module. If I now say cargo build, which is the .NET build equivalent for cargo, we will see it will be done. And if we then look into target, we will see that there is a WASM WASI compiled as well, which will be in build or not. So let me see. So if I now go back to the host, because I need to take this module, I have a copy script in my host where I'm going to use it. So let me switch to the host, the console app that hosts all of this. We will see that the module itself is being copied here. So this is just a copy script that takes the target WASM that we just compiled and puts it into this directory so we can use this. And then we take the program and then it will start. And what we do right now is that aside from taking WASM time as a console thing to run it, we're going to say, hey, we're going to run WebAssembly WASM time inside of .NET. And the cool thing is that they have released a lot of packages that will allow you just to do that. So I have a WASM time reference to that version 3.0, which has been released a couple of weeks ago. And then we can just take a WASM module and run it. And there's, as I said, it might feel a bit rough, but there are some things happening that we need to do. We need to make sure that we have an engine, that we link stuff, that we have a store for our module and our data to consist in. And then we're going to say, load this module, instantiate this module, and then get the function main. And then we're going to invoke that function. That's exactly what we're going to do over here. And one thing, so I also pass through arguments to the module itself. So the arguments from the console app from .NET are being blindly passed on to the module that's being run inside our WASM time in order to do the copy, because I want to do a copy from to file, right? So if I now look into the directory where the console app is, and then say .NET build, just to be sure that I've not broken anything, we can say .NET run. This will take this application, this will execute, this will take the module that we have just written. And what you also see over here is there is a folder with log output. So let me, I believe are empty right now, these two, yes. The WASM time has been instructed to write its output to those log files so we can see it. So what if I'm going to do the same that I did before? I want to have the etc host file and I want to copy it to the host file in the current directory. Then what we're going to see is it will run. But if we then look into the error log itself, we will see like, hey, error opening input etc host file. So this comes from WASM time, which it instructs like, hey, failed to find the pre-opened file descriptor that allows us to open etc host, right? So we have seen this in the first demo. So right now, this is the WASM runtime inside the .NET thing that will do exactly the same. In order to fix this, we need to do the RX of saying, hey, we need to open a folder. So with pre-opened directory, we can say, hey, this module is allowed to read etc. And you also can give an alias, so you can even do some funky mapping, but we're not going to make it any more difficult than it is right now. And as I said before, the default folder of the application itself can also not be accessed. So we need to make sure that we also grant the module access to write to its own folder by default. So let's do that. Save it. So if we now do the .NET build, just to be sure that I haven't broken anything within our .NET code at least, and then we're going to say .NET run, the one that we did before, we will see that the etc host file is being written to this same folder, right? So this is the same file we saw before for my system that's been written to the local file because we instructed the WebAssembly module to have access based on the runtime that we see over here. So this is, once again, the whole file system access, which you can limit and you can use. And as I said before, you can also take it a bit further by saying, okay, we have file system access, but we can also work something out with relation to compute. Because if a module becomes malicious, it might do a lot of operations that we probably don't want it to do, or we want to maybe cut off. So what if we can give him like limited compute availability? And there within the WASM time or WASM in general, there is a concept called fuel, and fuel is a tick that will be done by each of the action that the WASM WebAssembly runtime does, and then it will consume fuel. So we can limit fuel that it is allowed to consume. So that's exactly what I'm going to do right now. I'm going to say, hey, this engine is going to run with fuel consumption in mind, and we're going to say we're going to add fuel because we need to be explicit about the amount of compute it can do. And then at the end, I'm going to ask the same module, please give me the consumed fuel that you have used during this action. Hopefully it's enough. We're going to see straight away. Let me just quickly delete this file so we can rerun this. So let's do the run again. Let's do the .NET build first. Of course, we want to make sure I haven't broken anything, because typing can be really hard, as we've noticed. And then if we do the run again, we will see that it also puts out, it will copy the file again, but it also shows us that it took about 35, almost 36,000 fuel to do this action. What if I'm limiting this module to 30,000 fuel? Delete this file. What will happen then is we will see that trap that I talked about before. Let me first do a .NET build, because this is of course .NET code that needs to be compiled in order to have the configuration changed, because we do it all in code. And then if I do the run, we will see that it will run into a trap, as I said before. And a trap is a execution stop that will take the thing, and it says like, hey, right now the execution has stopped. You also notice that the file is being copied, but that was an action that it was already done with, right? So the fuel consumption is really just compute that takes place, and it will stop itself. But you can imagine that if a module becomes malicious, you have the ability to cut it off and say, hey, you're not allowed to continue anymore, and you need to stop doing this. This is also a safeguard for that perspective. So we can take care of both files and we can take care of both compute. So overall, this is a whole demo, and I was looking into like what would make another cool demo is that I've now compiled a module with Rust to run on top of WASM time, on top of .NET. And within my demo folder that I've also published on the GitHub repo that will be released with this .NetFlix is a demo that takes .NET, runs it on WASM time, that runs on top of .NET. And you can also question yourself. I'm not sure if there's time left for me to show it. It is almost the same concept. There's some rough edges because WASI SDK is definitely not up to par, but we can do it, right? And I've been doing sandbox in .NET in some of my previous talks as well, and it's just fun. So let me just quickly show you what I'm doing. Maybe not even run it because it's almost the same, but I thought this would be fun. So what we have here is a guest. A guest in this case will be the one that's responsible for doing the file copying, right? So this is the thing that we will compile into a WASM file. That's exactly what we do. WASI SDK is included as a project reference. So if we build this, that will happen. The only thing is that WASI SDK right now doesn't take care of arguments being passed on, and also the way that you communicate with a module. You need to have some type of interface types, and there's a whole WASM component model that they're working on right now, where you can just create a definition of this component looks like this and needs to have these arguments in order to execute. Right now, it's not there. So what I'm doing for the .NET one is just take environment variables, put the arguments in there, and then say we're going to copy. And within the host, you're probably going to see a lot of stuff that's familiar to what we have seen before. The configuration, the pre-open directories, it's all the same. I'm taking the module that comes from there. Let me quickly see if this is in a state that we can execute this right now. I believe it is. And you also see that I put in a fuel consumption of how much is it? 10 million, 100 million, even more. You can probably imagine that the whole .NET thing is not efficient. So for that reason, it's not a good example. But as I said, I think this is just cool. So if I say host and then .NET run, and then etc hosts, I believe I did exactly the same. We see what it is, and then it says it has no file access because I didn't grant the access on the folders. I saw that one before here. So let me quickly just show you the happy path that it will work. So let's say once more in the upper folder, by build and then .NET run, and then I haven't parsed the arguments. And then it says it has not been, but it has copied, right? So it stops probably because of fuel consumption, but it has copied the file, so it works. So the cool thing about this, we can also do .NET on WebAssembly on .NET. Do you want it? No. But if you look at the whole WebAssembly module as a whole, and that's mostly the component model and the worlds model that they're going to work on right now. If you look up, Luke Wagner has a real good talk which he done, I think, at WASM Day of Cloud Native that happened in October or November of last year in Detroit. He explains exactly what the vision is for this, but it's just as in the old days, we had composite applications where you had modules that you run inside your application, right? And you can just see them as the same, and it will be as easy just by getting a module that describes and that will explain how it works and what type of WASI calls it needs to be executing on. So what does it needs to have available in order to be successful in execution? What type of writes does it need? I need to have write access to this folder, or I need to have a location where I can put this, or I want to do external communication to that server in order to be successful, right? So that's the whole model, and that's where it all comes together. And is this almost the same as COM plus or DCOM? Or there are similarities, but this is not like focusing on the distributed part. It's mostly focusing on taking the composite modules applications, and you just write in every language you want and just combine it and have a module that has limited access. And I think that's quite powerful as a concept. So this is the last demo I had for today to show you. But as I said, I think this is technology that we're probably going to see a lot more, definitely in the cloud native space as well, like doing workloads, functions. We have seen that already, but modules itself can be you can even do trusted computing with modules that run against a trusted part of your processor, a T. NRX is a real cool project that does that. That's also WASI based runtime that runs without any virtualization layer on a machine, which is makes it really good suited for sensitive data handling, for example. And you can still take .NET, Rust, Python, Go, whatever, and run it in that context. So I think I think that's really cool. That makes me excited to do this kind of like combination of technologies and just use it all combined, right?
Yeah, and in a safe manner, right? Because that's really important.
Yeah,
Combining this stuff is really, really nice. And if you have some kind of a library laying around in some programming language that you want to use, but yeah, you're already standardized on .NET, but now you can combine stuff and also make sure that it's all locked down so people cannot do any crazy stuff inside the host. So that's pretty cool. Yeah,
you cannot do anything like by default unexpected because you set the expectations. If you look at the whole component model, the host module that takes care of the whole graph of modules is responsible for defining that, and that's exactly what you want, right? You can just take that per third party thing and with a bit more trust run that. Yeah, for sure.
Mm-hmm.
Cool.
And if you look at you pre-open these folders, right? Because you wanted to read or write to them.
Yeah.
Does this all have to be done at the beginning when you are building this component model, or can you expand that later on?
No,
of course, with the right permissions, but you have to do it all predetermined, right? So
predetermined. Yeah, it's the same. It's almost like when a module gets loaded, it will be allocated a specific chunk of memory, and that's it. And this is exactly the same. It will just have access to that, and you cannot change it at runtime. Cool. At least not as far as I'm aware of, but that's not the model. Yeah, so.
Yeah, it's a really cool playground. So it's like you said, it's still early, but yeah, I think that it's really cool that people like Steve Sanderson and all these guys that are these very smart guys are working on this stuff. And and I think the standardization will also become really important because these interfaces, this WASI standard, it has to be all standardized, and then you can exchange a lot of stuff. So
and the Bytecode Alliance, there's a big group of people that came from Mozilla Firefox that started all like this in 2017, and right now most of them are all with Fastly doing still the same, and they are like focusing on that standard. Microsoft is involved, right? It's Google, it's Amazon, because a lot of the Amazon Prime stuff that they do inside the video software is WebAssembly modules, right? So, and they can compile quickly, almost native against every 7,000 different devices. So it's a powerful ecosystem, right? Because it's compilation target. Then that makes it really cool for sure.
Yeah, lots of opportunities. So we would like to thank you for showing us this and doing these cool demos.
Yes,
so
sure.
I hope everyone at home also enjoyed this. So if you like us, please subscribe to the dotnetFlix YouTube channel, and then we'll see you at the next episode. Have a good night. Bye-bye.
Bye.